This is the video for 7.3. It is our third one on conics. It's about the parabola. So the parabola is interesting because it is a conic. It's the size, the shape that comes down here, but it's also the thing we've studied several times, right? So we're taking a different look at it. We'll have a little bit different formula in the way we can look at that formula, and it has a lot of interesting ways that it is used in the real world. So the definition of a parabola is it's the set of points that are all the same distance from a point called the focus and a line called the directrix. So in this picture here, you see that here's our line, the directrix. I should make a different color since everything is red in that picture. So here's our line, the directrix, and here's our focus. And you see that this distance is the same as this. So the distance from the line, the perpendicular distance, that's how we measure distance to a line, is the same as the distance to that focus. And so if we looked at this point right here, it's on the parabola because this distance to the focus is the same as this distance to the line. So in this figure, we can look at some of the terminology we're going to use for a parabola. So there's a focus and a directrix. That's the point in the line, right, that we're doing the distance to. In this picture, they're marked in pink. And the line that's perpendicular to the directrix but goes through the vertex, that would be this line right here, right? That is the axis of symmetry. And we talked about the axis of symmetry when we talked about the square function, which was a parabola. And that's the place it goes through the vertex, and it's the same on either side of it, right? It's symmetrical. The vertex is that tip where it changes from one side to the other, right? Then, so the distance from the vertex to the focus, that is called P. It's usually referred to as P. It's the length, which is absolute value of P, often called the focal length. So it's how far it is just from the focus to the vertex. That's P. So it is also the distance from the vertex to the directrix, because they have to be the same, right? Any point on the parabola, and the vertex is on the parabola, it's the same distance if you're going to the focus as if you're going to the directrix. So those two are both P, as it shows right here, right? They're both P. So we have always before talked about parabolas going up and down. A vertical parabola, meaning the axis of symmetry is vertical. That's the only one we talked about when we talked about them before, because that's the only one that's a function. But now we're going to talk about both vertical and horizontal. So first the vertical one, which is the one we know a little bit about. So this is our equation that we're going to use, right? X squared equals 4py. So see this x squared, you know what an x squared function is. It's opening up, right? If p is negative, then this would be a negative number over here, and that would mean it's open down. It opens down. Okay, so this P is the P on our graph. Okay, so it is the distance from the vertex to the focus. So in this case, the vertex is 0, 0. And that would mean that the focus is 0p. So because it's going up and down, we're going to go up however far p is. The directrix would be the other direction, right? And it is a horizontal line. So it would be the line y equals negative p. So if p is greater than 0, it opens up. If p is less than 0, it opens down. So here's our picture. This is like the other one we had, right? This point here, oops. Okay, so this is how far, this is p, that distance going down, it's the opposite of p. And this would be a horizontal line, so y equals negative p. That's what it would be. And then our focus would be up p. So it would be 0p. That would be our focus. Ugh, come on, let me get this back in form here. And remember that the vertex is right in between the focus and the directrix. Right? So here is what it looks like horizontally. So what do you notice is the difference with this equation? So in the other one, we had x squared, just like we've always had the square function, right? But in this one, it is a y squared. So if the y is squared, then it's opening up to the left or the right. And same as before, you go over p up 0, that will give us our focus. Our directrix is the opposite direction. So if it's opening to the right, if p is a positive number, then here's our vertex, and we're over p. That gives us our focus, and back p gives us our directrix, and it's a vertical line this time, right? And it's x equals something, right? It's x equals that negative p, or opposite of p, because if p is a negative number, then this whole picture would be switched around. So here, let's go back here. If p is greater than 0, it opens to the right. If p is less than 0, it opens to the left. And we would know because there would be a plus or a minus here. I don't know why my laser pointer doesn't work half the time. We will do those. Okay, so I want to look at a couple other things. So right here at the focus, if we look at a line that's parallel to the directrix and it goes through the focus, that would be this line that goes straight across here. And it's useful to know about this line because, first of all, it's really easy to find the length of that line. And when you're graphing this, we don't have to worry about the stretches or the shrinks like we did in the square functions we did before in the parabolas. We are just looking at the width of that line. So from this point, this focus, so whatever p is over here, right? So if we draw p straight across, so it's horizontal, and then we look at what it would be coming down here, those two things have to be the same because that's what p is, right? P's on the parabola, and the distance to the focus has to be the same as the distance to the line. Well, since this is a horizontal line, it's the same height as the focus. right? So this right here is a P. But this down, that's the distance from, that's the same as the distance from the vertex to the focus, right? But this down here is also a P, because remember the distance from the vertex to the directrix is also P. Okay, so this is 2P going down, then this is 2P across the top. And that's only half of it, so the whole thing is 4P. This line that is 4P long, this is called the latus rectum. Where did it go? Here it is. And it's Latin for something like the side straight line or something like that. But it's useful because, what did we just say it was? 4P. Well, does 4P sound familiar to anybody? Oh, there it is, 4P. 4P is what our equation was. Maybe we should go back. There it is. There is our 4P, right? So 4P, that's the number in front of the X there. So it's super easy to know without doing much figuring out, easy to know what that is. So let's just look at where all this stuff fits onto a graph. Here is the graph, but let's just find all the things from our equation. So this right here is 4P. Remember, the equation is y squared equals 4px. So if 4P is equal to 20, then I can divide by 4, and I know that P is equal to 5. Now, in this case, we don't have any shift, we don't have any H and K, and 0, 0 is the vertex. So there's my vertex. I've already got the graph here, I know, but there's my focus right there at 5. Okay, so remember that the focus is always going to be on the inside of the parabola. Whichever way the parabola is curving, that's the direction of the focus, because it's inside the parabola. And the directrix is away, and remember, it can't cross the directrix because it's always we're looking at that distance and the same being the same as the distance from the focus, so it's only going to get farther and farther. It can't cross it someplace because then the distance would be 0, but it's not crossing at the focus, so that wouldn't work because it wouldn't be the same anymore, right? You can almost picture the parabola as being repelled by the directrix, right? It kind of pushes away from the directrix. That's the way it opens. All right, so there's P. So the directrix is the opposite direction from the inside of the parabola, right? So if the parabola opens to the right, which this one does because 20 is positive, then we would go to the left to get the directrix, and the directrix would be the line x equals -5. Right, so that would be our directrix, x equals -5. And our focus would be going the direction the parabola opens, that P amount, right? So that's going to be 0.50. So lots of things we could look at. So the axis of symmetry, that is when we go perpendicular to the directrix, but right through the vertex, right? That's our axis of symmetry. And so that in this case would be the line y equals 0. And then we have that latus rectum, which goes right through the focus and is parallel to the directrix, right? It's that length. And how long should the latus rectum be? Well, it is that number right there, that 4P. So we would go from the focus, we would go 10 on each side. So you split it in half. It would be 10 this way, which, see, it's coming out here at 10, and 10 this way. It's having that here at 10. So that thing is 20 across, and that is how we know when we're graphing it how big it is. All right, so let's look at the equations that we have for something that has been moved around. It's not vertex at the origin. It's shifted somewhere, right? So first we'll look at the vertical one. And so just like before, it's the same equation. So if you know that x squared equals 4py, all we're doing is putting that x minus h instead of x and y minus k instead of y. And that means that the vertex is at hk, right? That's what we've done, is we've shifted it. So down here at hk, that is our vertex. Okay, now whatever p is, our focus is going to be up from there. And so p, it goes up p. So the x value is the same, but the y value is added p. So h is the x value still, but k plus p, now that will be the y value for the focus. And the directrix, we go the opposite direction. So from the vertex, it would be down p. So y equals, it's a horizontal line, y equals k minus p. And the axis of symmetry is going to be that vertical line. Since the directrix is a horizontal line, the axis of symmetry is going to be a vertical line that goes right through that vertex. So it would be at h, x equals h. So we gave this example and drew this example when p was greater than 0, so it was facing up, but everything would just be flipped upside down if p were less than 0. All right, so let's look at the horizontal one. So that is going back and forth, and we're giving the example again in the graph of the p being positive, but all the formulas work just as well, and the graph is just switched back and forth, or backwards if p is negative. Right, so as you can see, in place of y, we have y minus k, and in place of x, we have x minus h. So it's the very same as ellipses and hyperbolas. It doesn't matter the order that they come in the equation. We're just replacing x with x minus h, and we're replacing y with y minus k. And that gives us a vertex of hk. All right, so the focus, this time the focus is changed. The x value is changed, but all the y values are the same. So I'm going over, instead of going over to h, which is my vertex, I'm going to go h plus p. Right, and so the same way, I'm going h minus p to get to my directrix. And it's a vertical line this time. And the axis of symmetry is a horizontal line, since the directrix is a vertical line, right? And that's the same thing for the positive ones are going to the right, negative ones are going to the left. Okay, so let's do some practicing. In this one, this is in our standard form, just like we just saw it. And we're going to find out all the information about this and then graph it. Let me get a different color. All right, so the first thing is we look at and say, is this opening up, down, left, or right? Because we need to be oriented so we know which way we're taking things, right? So we tell that by looking here. So it's a y squared, not the x squared, the y is squared, right? So it means it's either right or left. And we look over here where this is negative, and so we know it's opening to the left. So it's going to the left. And p is, remember that this number, this negative 8, has to be equal to 4p. So if I divide by 4, I get that p is equal to negative 2. right? So it's opening to the left, and our vertex is that HK in the shift, and we start with the X value. So we have X minus 4, so the X value of the vertex is positive 4. And we have Y minus 2, so the Y value of the vertex is positive 2. All right, so if I'm graphing this, it's going to be over 4 up 2. Okay, so the focus is going to be from that vertex. I'm going to go to the left because it's opening to the left, right? So I'm going to go negative 2 from that vertex. So the vertex is at 4, the X value, right? So I'm going to subtract 2, and I get 2, and the Y value will stay the same. So my focus is going to be right there at 2, 2. Sorry, I don't write very good with styluses on screens. Okay, the directrix has to go the other direction. So it's going to be 2 the other way. We're going to add 2. And that is going to give me this vertical line right here at the edge of my graph, right at 6. So it's going to be the line x equals 6. So remember, I had to take this 4 and add 2, right? So the length of the lattice rectum is going to be 8. And so what that means for my graph is I'm going to go at this focus, and I'm going to split the 8 in half. So I'm going to, from the focus, I'm going to go over 1, 2, 3, 4, and 1, 2, 3, 4, and that is that is the width of my parabola. So it's going to go through the vertex, it's going to go up through those terms there. Okay, so just like before, sometimes it's not going to give it to us in a nice format. It's not going to give it to us in the standard form. So the standard form is that form we looked at on that chart, right? And this is in the general form. So we have to complete the square. All right, so we've got y squared minus 6. Nope, yeah, 6y. And then I'll put the other ones on the other side. 16x minus 9. So I move those over to the other side. And then I'll complete this square here. So half of negative 6 is negative 3. And I square that and I get 9. So I have to add 9 to this side. All right, so on this side, the negative 9 and 9, they cancel each other out. So I just have 16x. And on this side, I have y minus 3 squared equals 16x. Okay, so does it open up, down, left, or right? So the y is the one that's squared. So it's opening either left or right. But the 16 is positive, so it's opening to the right. And the 16 is 4p, so p is 4. All right, so the vertex is going to be where that's shifted to, and there isn't one on the x. So the x value of the vertex is 0, and the y is 3. So over 0 up 3 is my vertex, and it's opening to the right. So the focus is going to be from there over 4. So I can draw it, 1, 2, 3, 4. Notice that because it's opening left to right, all the y values are going to be the same on the vertex. and the focus. So that will still be 3, but I'm going to have 0 plus 4 for my x value. Then I'm going to go the other direction for the directrix. 1, 2, 3, 4. So that is going to be this line right here. So that will be the line. It's a vertical line. X equals -4. The length of the latus rectum is that 4p number right there, so that's a 16. So I'm going to split that in half, and it's 8, so I'm going to do 8 on either side, right? So I'm going to go down 8, 1, 2, 3, 4, 5, 6, 7, 8, and up 8, 1, 2, 3, 4, 5, 6, 7, 8. And those are the endpoints of my latus rectum, and then I will sketch the graph. Oh, I kind of missed. There we go. Okay, so here's another one. I want you to try it. So pause the video and see if you can complete the square and get it into that form just like we just did in the previous one. Remember, we'll put all the x's on one side and all the other stuff on the other side. That's how you start. All right, hopefully you got it. We're going to have the x's on one side. I'll leave a little space to complete the square. And I'm moving them to the other side, so that's why I'm changing their signs. All right, so this one is a 9, and so I have to add 9 to this side. That makes it x minus 3 squared. And this side is going to be negative 12y plus 24, which means I can pull out the negative 12, and I have y minus 2. So you want to make sure that you pull out what's in front of that y, or when it's switched around the x, because that's the equation. Remember that it's the number in front of the parentheses that we're looking for our 4p. All right, so does this open up down, left, or right? Hopefully you saw that the x was squared and it's negative, so that's going to be down. All right, and p, well, negative 12 is equal to 4p. So if I divide by 4, I get that p is equal to negative 3. And the vertex, which is that shift, so I have x minus 3, so the vertex is 3. And I have y minus 2, so the other part is 2. So we're going to go over 3 up 2. And we're going down. So to find the focus, I need to add that p to my, so all my x values are going to be the same. So it's still going to be 3, but I'm going to take the 2 minus 3 and get negative 1. So there it is. That's my focus. My directrix goes the other direction, so it's going to be y. I got 2 plus 3 is going to be 5. So here's my directrix. So the length of the latus rectum is 12. So we're going to go from the focus. We're going to split the 12 in half and go 6 on one side. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. And that is where we draw our, oops, okay, not exactly. All right. close. Okay. All right. I want you to try this yourself. Go through and complete the square and then find all these different things and graph it, and let's see if you can do the whole thing yourself. Okay, so we're going to complete the square. We have y squared plus 6y, and I got negative 2x minus 5. So I know I did way too many examples with a 6 for completing the square, but so it's going to be a 9, and I'll add 9 to this side. You guys will be good at this particular completing the square. So this is going to be y plus 3 squared, and this will be negative 2x plus 4, which means we can factor out the negative 2, and we have x minus 2. Equals. Okay, if you can read that. So, does it open up or down, left or right? So because the y is the one that's squared, we know it's either left or right, and because the 2 is negative, we know it's to the left. So it's to the left. So this time, what is p? What did you find for p? So I know that negative 2 equals 4p. So if I divide by 4, that gives me negative 1/2, right? So p is negative 1/2. Okay, it's okay if p is a fraction. That's perfectly fine. So the vertex is at the shift, right? So x minus 2 means that the vertex, x part is at 2, and y plus 3 means the y part is at negative 3. So I've got 2, negative 3. There's my vertex. So the focus is going to go to the left because it opens to the left, right, by 1/2. So instead of going over 2, I'm going to go over 1/2 less than 2, right? So, or 1.5. I'm just going to leave it as a mixed number because that'll be easy for me to graph. It's still going up 3. So, well, I don't know if it is easy for me to graph. Maybe I should try a different color. Let's try so they can be close together. Okay, so it's there at 1/2. And the directrix is the other way. It's going to be a vertical line at x equals 2.5. Right, so it's going to be this vertical line that goes right there. So they're super close together, but that's okay. Now my length of my latus rectum is coming from this right here, so it's 2. I'm going to split that in half, and from this focus right here, I'm going to go over 1, up 1, and down 1. All right, so that is going to be how wide it is right there. Okay, let's talk about some applications of parabolas. They are actually used a lot, and you have all probably, in fact, you probably are using often satellite dishes. Satellite dishes are paraboloids, right? So they're in the shape of a parabola, but three-dimensional, right? It's like a parabola that's been spun. And the reason why they are so good is because the focus will be the place where you receive, but everything bounces off the dish in a way. I guess I don't have one. Oh, okay, let me show you. Is as sound or rays or light come into the dish, they are bounced into the focus. I don't know what this is, if this is the focus, could be. Then everything comes in and bounces into there. So everything gets put into that focus, right? So that's why they're great for a receiver. But they're also great for sending things out. So like a flashlight, flashlights are usually shaped as a paraboloid, and they have the light bulb at the focus. Right? Bridges often go in their paraboloid, as especially suspension bridges, when they hang down, the wires hang down, they hang in this paraboloid, a parabola. So gravity seems, just like we talked about with, just when we talked about gravity with a falling object, when we talked about parabolas before, it gravity pulls things in a way that we get parabolas when gravity is working on it. So there's the water, or there's a bouncing ball. It bounces in the shape of a parabola. So here's a word problem that could be, we'll do two word problems quickly here. And again, the nice thing about word problems is we set it up on the easiest possible axis, and to make it an easy problem, right? Easy formula, easy equation. So in this one, they're telling us that there's this satellite dish, and they can tell you that the receiver is at the focus, and the receiver is 8 inches up from the vertex. Okay, so what does that tell us? Well, if the focus is there, then P is equal to 8. Okay, so the dish is 18 inches deep. You notice that's not the same as the receiver, right? What they're saying is that this dish at its highest point, right, is 18. And so we go over some amount, some x, and up 18. That gives us the edge. And what they're asking for is how wide is the dish? Well, then, in other words, we want this x plus this x, so whatever 2a. They've got a written here, right? Well, first of all, let's just write the equation. So this is going up. It's centered at, the vertex is at 0, 0. And so this is just going to be the equation, x squared equals 4py. And I know p is 8. So I have x squared equals 32y. There's the equation of the dish, right? And I know I want to know what a is when y is 18. So I will just plug in 18 for y and then solve this equation. So 32 times 32 times 18 is 576, and the square root of that is 24. All right, so that's telling us that this length is 24. So the width of the whole thing is 48. And we're in inches. Oh, I got inches already. Okay. All right, so there's one sort of thing we might ask about. I might also give you some of the other dimensions and ask you to find the focus, like where should we place the receiver or something like that, right? So this one is a little different. This is a bridge, but it's in the shape of a parabola too. And we're also making the parabola, we're setting up the parabola so that the tip of the parabola is at 0, 0. And they're saying that they're giving us some numbers. They're saying these towers at the end are 49 meters high, right? And that's 49. And they're saying that the whole length from one tip to the other is 112. So if here is the vertex and this is 112, that means this point right here is 56 over, because that would be half of 112, right? So 56, 49, that's that point. I'm set up at 0, so I know it's going to be x squared equals 4py. And I know that the point 5649 works. So I know that 56 squared is equal to 4 times p times 49. And let's see, that turns out 4 times 49 is going to be 196. And 56 squared is 3136. So if I divide that by 196, that comes out to be 16. So P is equal to 16. So now they're asking us, what is the height of the cable? In other words, what is Y when X is 40? So when it's 40 meters from the center, what is the height? So X is 40. Okay, and I've got 4 times P, which is 16, Y, and I just need to know what Y is. So I have 40 squared, which must be 1600, and then 4 times 16, oh, well, if I divide by 16, that'll be 100, and then I'll divide that by 4, so that will be 25. That is not a Z, that is an equal sign. All right, so 25. So I'm saying that height is 25. Okay, so that's it for parabolas. We have one last thing we're going to talk about quickly, and that is when you are looking at conic sections in the general form, it's pretty easy to tell what kind it is without actually doing any work. Okay, so if you notice, like here's the general form, and sometimes we write b as the y squared term, but typically there is a term missing here that for all the ones that we do is always 0, and that is the x times y term. And so that's why we skip b. But so A and C are the ones we look at, and A and C are the only ones that matter, right? The rest of them don't matter, but it's A and C that are the important ones. I should do something I can write with. Okay, so if A is 0 or C is 0, what would that mean would happen to the equation? If A is 0, then I would just have this, the first one would be gone, and I would just have a y squared. I wouldn't have an x squared. And if C is 0, I would just have an x squared, and I wouldn't have a y squared. And so that's the one we just did. That would be a parabola. So that means that there's only one variable that's squared and the rest are not squared. All right, so if either A or C is negative, but not both, but one or the other is negative, then that would mean that it's going to be, when you complete the square and everything, they're still going to have opposite signs. They may not be the same signs, but they will still be opposite from each other. So that's a hyperbola. If A is equal to C, or A does not equal C, but they're both positive, or we could actually say they're both the same sign because it's possible we could divide. And anyway, but usually they're all negative. I mean, usually they're all positive because we usually make the first one positive. So they have to be the same sign, but not the same number. Then that's going to be an ellipse. If they are exactly the same number, then that's a circle. All right, so let's just look at a couple of examples. So we are going to determine which it is and then find that center or vertex. So I'm looking at the x squared and the y squared. So there's an x squared and a y squared. These are not necessarily in order. If we had this in the general form, these would be switched, right? But it doesn't matter because we just care about those terms. They're both positive and they are not equal, so this is an ellipse. To find the center, we would need to complete the square, so I would factor out a 2 from the x terms. I'm having such a hard time. Oops, I didn't want to do that. Okay, and then I will have the y terms, and then I will put the 9 over here, and this will be a 1, and that means I added 2, so I'll add 2, and this will be a 9, so I'll add 9 over here. All right, so this will be 2x minus 1 squared plus y minus 3 squared equals 20. Now this is not yet in the final form, but it is far enough that I can tell what my center will be. And since it only said to find the center, we'll leave it at that so we can, this video is probably long enough already. And so there's the center. Now this one, you see they're on two different sides. And so I really need to get them onto the same side in the general form before I can tell. So pause the video for a second and put all these on the same side, and then complete the squares. All right, hopefully you did it. We have 16x squared is 32x. I'm going to put that y squared over here and the 6y over here. I might as well leave the 57 over there. Okay, so I'm looking at these two terms, and they are opposite signs. So that means this is a hyperbola. All right, so if we factor out that 16 minus 2, factoring out a negative, so I will add a 1 here, so that means I'm adding 16. And I'll add a 9 here, so that means I'm subtracting 9. All right, so it's 50, it really doesn't matter what that is, does it? For this problem, anyway. Let's see. So it's 57 plus 7 is going to be 64. All right, so we could finish getting this in order pretty easily, but for my center, I have 1, -3. All right, So this one is going to be only one squared term, so this is a parabola. And if we complete the square, we got y squared minus 2y. Put the other things on the other side. So this is a 1. So this is a 1. And I'll factor out, oh, this is a negative 4x plus 13, which means we're getting some weird fractions. I'm factoring out negative 4, so this is going to be negative 13/4. By the way, when you factor something out and it doesn't go in nice, you can just do that division. That'll tell you what it is, right? 13 divided by 4. You know, so when you multiply it back in, the 4's will cancel. You get the 13, right? Okay, so my vertex is 13/4 and 1. And last one. And you see that they are both the same. So this is a circle. And I actually could get rid of all the 2's. I think I'll do that. I'll divide through by 2 on everything. While I'm at it, I'm going to switch the order. So this is going to be a 9, so I have to add a 9 over here. And this is going to be a 9, so I have to add a 9 over here. So this will be x plus 3 squared plus y plus 3 squared 18 equals 14. And that means that my center of the circle is negative 3, negative 3. Okay, so that's kind of how you tell what things are quickly by looking at it. Hopefully you tried some of those without seeing what I did first and beat me to it. And I will answer any questions you have on this in class. So long.